Welcome back to our flipped classroom, part 3 about learning about decimals. Now, we've been looking at decimals as a quantity using grit, or thinking about it as money. And we know that we have hundredths. So if we had one whole and we split it into 100 parts, each part is called a hundredth. And we also have talked about tenths. Tenths means that if you had one whole and you split it up into 10 parts, each part would be a tenth. We would need 10 tenths to make a whole. We would need 100 hundredths to make a whole. But what if we were to think about it as a linear amount? Let's take a look at our Apatosaurus. I think that's how I say it. And if we were looking at its height, we would notice that it's 1 full meter, 2 full meters, 3 full meters, 4 full meters, 5 full meters, 6 full meters, and part of another meter. So I would say that this is 6 and I'm going to guess 6 tenths, 6 and 6/10 meters high. And if I was to look at the person, and this actually makes me kind of glad that dinosaurs are extinct because I couldn't imagine going for a walk and meeting one. This person is 1 whole meter tall. They're not quite 2 meters tall yet. I would probably say that they're 1 and let's say 8/10 meter tall. And so this is another way to think about decimals as a linear measurement. So take out your printables now. This time you're looking at the number line, and let's investigate one first. So here we have, let's say, meters. 1 meter, 2 meters, 3 meters, 4 meters, 5 meters. If we were to take a measuring stick, it would be like this. And each section is split into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these represent tenths. So I've got 1. We've got 1 full meter and 1/10. Oops, that wasn't very good. 2 tenths, 3 tenths. So this is 1 and 3 tenths, because this is in the ones place value column. This is representing, now we're getting into quantities less than 1, and this is our 10th column, so 1 and 3 tenths. Now I really could think about it as 1 and 30 hundredths as well, if I wanted to. If I was thinking of it that way, that would mean each of these sections would be 10 hundredths. So 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, 80 hundredths, 90 hundredths, 100 hundredths, or 1, 10 hundredths, 20 hundredths, 30 hundredths. So that's how I would represent it as a linear measurement. All right, grab out those printables like I mentioned. And now I want you to show me, put a dot where you think 3 and 7/10 would be. So think about that. We need 3 wholes and 7/10. That's what it would look like. 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7/10. I need 3 more tenths and I would actually be at 4. So if I was actually rounding this, I would say that 3 and 7/10 is close to being 4. If I was rounding it, it's closer to 4 than it is to 3. But we'll leave that for another day. Okay, next one. Now show me where you would place 4 and 2/10. There we go, 4 and 2/10. This is 4, our whole number, and 2 more tenths. Okay, one more, and then we're going to make it harder for you. 2 and 1/10. There we are. 2 and 1/10 would go right here. And we can see, if we were rounding, this is actually close